Hello everyone, this is Aditya and today we'll discuss this question. It is from complex analysis, so let's start with the discussion. But before that, please do like, share, subscribe my channel and please support this video. Now let's start. And before that, I need to tell you that I've already made a one shot on complex analysis till harmonic functions. So you can check out that video. It is for a BTech student, so you can check out that video. Now let's start. So let's understand the question first of all. So it states, show that every analytic function fz is equal to u plus iv defines two families of curve u is equal to c1 and v is equal to c2 which form an orthogonal system where c1 and c2 are constants. Did you understand? Well, basically we are asked to prove that every analytic function fz defines two families of curve u is equal to c1 and v is equal to c2 which form orthogonal systems. So we have to prove that these two are orthogonal curves. Okay, so c1 and c2 are constants. Okay, so let's see it. So what is the condition for orthogonal system? Well, the product of slopes must be equal to -1, right? Okay, so dy by dx for u times dy by dx for v, it must be equal to -1. Basically this is the case, right? So u is equal to c1, right? And we all know that u is a function of x and y, right? So what we can do is that we can differentiate. So we will have du, since c1 is a constant, so it will be 0. Similarly, v is equal to c2, hence dv is equal to 0, correct? Okay. Now we all know that dz is equal to, this z is different, okay? dz is equal to del z by del x dot dx plus del z by del y dy, right? This is known as the complete differentiation. Hence, u du is equal to del u by del x dx plus del u by del y dy. Correct? Okay. Hence, this expression is basically what? This is del u by del x dx plus del u by del y dy is equal to 0. So from this we will have del u by del x dx is negative del u by del y dy. Hence we have dy by dx is equal to del u by del x divided by the quantity del y negative del u by del y, correct? So this is dy by dx. Similarly, we can solve for from over here also. You can apply the same procedure, that del v by del x plus del u by del v by del y dy is equal to 0. So from this, it is just similar calculation. You will have dy, this for u, dy by dx for v is del v by del x divided by negative del v by del y, right? Now we know that their product must be equal to -1, right? Okay. Hence, del u by del x divided by the quantity negative del u by del y times the quantity del v by del x divided by the quantity negative del v by del y. Now we have to evaluate this stuff, okay? Well, this and this will become +1, so we can remove the negative sign. Now this is equal to ux times vx divided by the quantity vy divided by the quantity multiplied by the quantity, sorry, this is uy times the quantity vy, right? Now how we evaluate it further? Well, we all know Cauchy-Riemann equation. Since it is an analytic function, so it should satisfy Cauchy-Riemann equations, right? Which means that there must be a relation between ux and vy. We all know the relation, of course, and uy and vx. In case if you don't remember, just use this identity, that is this formula, fy is equal to I fx, right? Then it is very simple. It is uy plus ivy is I times the quantity ux plus ivx, right? Now just equate the imaginary term. So you will get vy is equal to the quantity ux and vx is equal to negative uy, correct? Now just convert ux into Vy, or you can do vice versa also, that you can convert Vx into U terms, the V into U, right? So you will get Ux is equal to Vy times the quantity Vx. What is Uy? Uy is equal to negative Vx times the quantity Vy. So this and this gets cancelled, it is equal to negative 1. Hence the product of slope is negative 1, which implies that this statement is indeed true. So if you enjoyed this video, if you did, then please do like, share, subscribe my channel, and please support this video. Bye bye, take care. And yeah, don't forget to watch the complete one shot on complex analysis which I have uploaded on this channel.